So our objective today is to learn how to multiply monomials. Now, when I use the word learn loosely because you should already know this. So this is just really reminding you how to multiply monomials. So monomials. So the secondary, the crux of what we're looking at is what do we do with exponents in a multiplication problem? Okay, so this comes out of Chapter 5, Lesson 5-1 from our green algebra book. We're still sticking with that one for a while. So I'm going to take you just a real little baby step, and then we're going to just kind of kick in, do some practice problems, and call it a day, okay? So let's start with, when you first were introduced to exponents, your teacher would ask you, what does that mean? What does 8 with the little 3 mean? What's going on in this problem that gives you this? Brian?
You do 8 times 8 times 8?
Yeah, oops, sorry, that's not an 8. All you're doing is a shortcut of showing a multiplication problem. That's all exponents are. It's a shortcut of showing you a multiplication problem. So it just means 8 times 8 times 8, okay? No big deal. So the question then becomes, well, what if I take 8 cubed and I want to multiply it by 8 squared? Well, I can break it down because I know what 8 cubed means. You guys just told me that was 8 times 8 times 8. But what's 8 squared mean? 8 times 8. So how many 8s do I actually have? And then your teacher may have said, okay, that's awesome, but that's really boring, the middle part. Is there a faster way of getting this answer? Can I just figure out how to get to 5 without having to draw out the dang thing? It's a waste of my time. Justin?
You add the exponents?
So what most people started realizing was, wait, 3 and 2 is 5. Whoa! And you guys did a couple of examples, and then you realized, oh my goodness, when I am multiplying monomials and the bases match, so 8 is a base, then I'm just going to add the exponents. Okay, so I'm going to go back. Let's add some vocab to this, and then we'll do some practice. So first vocab is, what do I mean by a monomial? So monomial is simply, oops, let me add a word, a term that contains, or let's say that may contain, may contain numbers, variables, exponents that are being multiplied or divided. Okay. So a monomial is a term that may contain numbers, variables, exponents that are being multiplied or divided. Okay? Jason? Well, then move yourself to where you can see it. Right next to Brian's empty. So what did you not hear me say in my definition? Yeah. Notice what's not there. And there's a reason for that. No adding or subtracting. Okay? Now, technically, you could say with division, that's actually just 2 different monomials. When you're adding or subtracting, it's 2 different monomials, or 3, or 4, or 5, depending on how many terms are there. Okay? So monomial, really all you're going to see is multiplication, and sometimes people will include the division on it. Okay, so for example, let's just do here. 2a squared is a monomial. Okay, there's a number, there's a variable, there's an exponent. It has all three of those components. Okay, 5x squared y. Now, some people will say, well, that's two monomials, and you're dividing them. But some people will say that's just one big monomial. Okay, that's okay. This 5x plus 3y is not a monomial. What it is, it's two monomials being added. Okay, so monomial, mono meaning one. Monorail monorail, it's on one track. Okay, mono, one rail at Disneyland. So, are you guys remembering that rule about when you multiply monomials, you add the exponents? Okay, so we're going to actually write that down. Just when we practice it with our hand, we tend to keep it in our brain a little bit better. So we're going to say, when multiplying monomials, and here comes a proviso. This must be met. If this condition is not met, then this rule doesn't work. When multiplying monomials that, and I'm going to yell at you, have the same base. So you have to meet that condition. When multiplying monomials that have the same base, add the exponents. So I'm going to box up the word multiplying and the word add to remind myself those two pair up when I'm doing my math. Okay. So just as a quick review, I have three different terms here, and I need to label them with what they are. Jacob, join us today. Okay. Now, I keep mentioning the word base. Only one of those values is a base. Which one would be the base? Spencer.
5.
Okay, actually 5's not, you could call him a base, but we're going to give him a better name than base. Delaney? Yeah, why? Yeah, you have to have an exponent attached to something, and that something is a base. So this guy is called the base. Now, in that, Delaney kind of gave away what 3 was called. So, Maggie, what's 3 called? He's the exponent. And instead, now, I have to say Spencer's technically right. 5 can be considered a base, but we have a better name for him. What's the better name that we give 5? Jason?
A coefficient.
He's called a coefficient. Okay? So, we'll do a couple practice problems, and then we'll talk about a different kind of problem. So we're only going to worry about multiplying tonight. And let's see, we're going 1 through 21 odd. And then, what else is there behind there? 39 to 49. Okay. Oh, a little bit of that. And then we've got 215, 11 to 23 odd. Okay. So let's talk about that. I'm just not going to have you do simple problems, right? Because you are beyond the simpler problems. So we're going to get a little bit more complicated. So I'm going to give you some problems. Directions are going to say simplify. And then you're going to hear often express using exponents. So they don't want the answer to be 5 times x times x times x. They want it to use exponents. Okay. So I'm going to give you one easy one, and then we'll get harder. Y to the 4th times y squared times y to the 5th. Okay. How many monomials do you see there? 3. Okay. Do they all have the same base? Yes. So we can use our rule. And how many y's do I actually have altogether?
3, 1.
No.
11.
You have to add the exponents. So you have 6 plus 2 plus 5, or sorry, not 6, 4. Plus 2 plus 5, and that gives us the answer of y to the 11th. Now, what are you going to do on your homework? You're going to write down the original problem, and you're going to write down the answer. You don't need to do the middle unless you get yourself a little confused and you need to see it out. Then you can show what the middle is. Molly, question.
I was just going to ask if we put on a test, we'd have to show our work like in the middle part.
Let's just say if you're having trouble adding, then you need to do whatever you need to do to stop having trouble adding. But I would say middle, no. Okay, so let's try one a little bit harder, and I haven't told you what to do with this before, so let's see what happens. I have x to the 7th, y to the 4th, z to the 4th, and I'm going to multiply that by x squared, y to the 5th, z to the 8th.
Z to the 4th?
Oh, I'm sorry. I said it and I didn't write it, did I? There we go. All right, so how do I handle this one? Because how many bases, different bases, do I have on this one? I have 3 different bases, a total of 6 bases altogether. What is going to happen? Amanda? So the only ones that can get added are the same base. So I can only put x's with x's. I can only put y's with y's. I can only put z's with z's. So let's look back what we got. X's, I have 7 and 2 for a total of 9. Y's, I have 4 plus 5 for a total of 9. Z's, I have 4 plus 8 for a total of 12. That's all you can do. You can't do anything more than that. You cannot make it x, y, z to the 30th power. Believe me, I've seen that answer. Okay? No. The x's stay x's, the y's stay y's, the z's stay z's. You cannot mush them together. Okay? All right, let me interject something else that's going to show up. And I don't know how experienced you are with this, so you guys are going to have to let me know. What does this mean? 3 to the negative 2nd power. What does that mean? Okay, Connor?
Negative 3 times negative 3.
It doesn't mean negative 3 times negative 3. Okay? The 3 is a 3. I cannot change what he looks like. All right, Jacob? It's not 3 times negative 3? No? See, this is good because now I know where you guys are coming from. Tristan?
3 times 3.
It's not 3 times 3. Because see, 3 squared would be 3 times 3, so don't you think 3 to the negative 2nd should give me something different? Okay, Patrick?
Is like negative 1 times the quantity 3 times 3?
No. Oh, my goodness. I'm going to try one more. Miles? Sorry, that's mine. Yeah. What the negative says is that this base has, every number has one of 2 locations. It can either be in a numerator or it can be in a denominator. When you have a negative exponent, what it says is the base is in the wrong location. So all we're going to do is shift it. So when I shift it, the negative becomes a positive. And I fill up the blank with a 1. You guys remember that now? Yeah, just like slowly coming back to your brain. So it would be 1/3 times 1/3, which equals 1/9. That's what its ultimate answer would be. Notice the negative had no effect on the value of the answer. All it had an effect was on location. Just like on a number line, if you think of a number as being -2, it just means it's to the left of the 0. A +2 is to the right of the 0. So all this is a location shift. That's all we do. And then we follow our basic rules.
A problem like that, you technically just do it like the normal exponent and then flip it.
You would be incorrect to say 9 over 1 equals 1 over 9. So actually, this would be, your protocol would be, if we had 4 to the negative 3rd, we would first write it as 1 over 4 cubed, and then we would say what 4 cubed is. Okay? Jacob.
Would those ever be like the following?
Anything is available at any time. So anything is possible. All right. We're not going to throw that at you today, right? Because we're just kind of beginning with this. So a negative exponent, let's just write this down. Oops, exponent. Let's see how to say that. Negative exponent means the base needs to move to its opposite location in a fraction. Once moved, the exponent is positive. Okay? And again, the value of the monomial is, I'm going to yell at you, not negative. Patrick, question.
Are we ever going to have like 0 and like a negative exponent for like an exponent?
It's a possibility, and what would that answer be?
Or, but if it's a negative exponent, would it be like undefined?
Exactly. So if you ever are forced to move a 0 into a denominator, then the answer is undefined. Okay. All right. So this is something to watch out for. You are going to practice a little bit of this. So let me show you a trick one. Oops, sorry. Let me try that again. If they asked you to rewrite 4x to the negative third power without a negative exponent, only with positive exponents, how would you rewrite that? And this gets a little tricky. This is where you have to really think about exponents. Okay? Connor?
4 over x to the 3rd.
Very good. What Connor realized is that the exponent was only on the x. So only the x is going to shift. The 4 had no exponent other than a positive 1. If we don't see it, it's a positive 1. So only the base that has the exponent attached, that's negative, is the piece that's going to move. Okay? All right, one last one real quick. What if you have this? 2x to the 5th y times 7x squared y cubed. How are we going to solve that problem? Brian?
You would multiply the coefficients and then you add the exponents of the bases.
Okay, good. That's exactly right. All we do is multiply the coefficients, but then we're going to add the exponents on the like bases. So here's my question. On the y, what's the exponent on the first y that you see? 1. If you don't see it, it's still a value. You got to account for it. So the answer to this problem would be 14x to the 7th y to the 4th. All right. Good luck studying.